computer science. Of what your part may be. Yeah.
Electronics and communication.
Electronics. Okay. How many are electronics? Couple more. Okay. Which discipline? Electronics. Okay. Any other besides computer science and electronics?
GIS and remote sensing.
GIS, remote sensing. How many people are from that background? Geography, GIS, remote sensing. Geography. Okay. So that's a good sizable part. Actually, folks who are from GIS, remote sensing and so on, if you don't mind, please stand up for a minute. And I would like the folks in computer science and electronics to take a quick look and at least make a friend with somebody in GIS, remote sensing and geography. So folks from those disciplines, if you don't mind, please stand up for about 30 seconds. Okay. Yeah, please just stand up. Yeah. Yeah, that's all right. Geography, GIS, remote sensing. Okay, so at least we have half a dozen people. Good. All right, let's second talk about the institutes. How many of us are from JNU? Okay, so about half. All right. So folks who are not from JNU, you can name your institution. So yes, which one? IIT Delhi. Okay, how many from IIT? All right, couple of us. Okay, 3. And I do know AAA IIT Delhi. How many? Just raise your hand. 2. Okay. If you haven't been, named so far, JNU, IIT, or IIT, could you please name your institution?
University of Delhi.
University of Delhi. How many people? Raise your hands. Okay, 1.
NIT University.
And IIT University. How many people from there? Okay, few. And please name other institutions. Okay, one at a time. Yeah. Jamia Millia. How many people from there? 2. Okay. Which any other? IP University, okay. Raise your hand. All right. Okay, any other? Okay, wonderful. And how many from there? 2. Okay, great. Any other institutions here? All right. Sharjah University, okay. Raise your hand. How many? Just 1? Okay, good. All right. So again, it will be good for you to kind of, meet some people from other institutions and other disciplines. That's another part of this course, helping people connect. Let's next also think about the level. So first, do we have any undergraduates in the room? Okay, few undergraduates, that's good. People at master's level? All right, quite a few. People pursuing PhD? Okay, looks like that's the majority. Postdoctoral research? Okay, good. At least a few. People who are working professionally, either in government or industry? Okay, a few, that's good. Let's also quickly go through the sectors. Folks who are in academia, either as a student or postdoc or teachers, okay, but majority working in industry, okay, a couple, and government, okay, couple, okay, good. So what I would also like to do is to spend about 5 minutes, letting you meet one of your peers, okay. So, but I'll, wait just a few seconds, and then we'll give you time. Introduce yourself to at least one person in the room that you haven't met before, and just exchange about your research interests, disciplines, what brings you together, or maybe if you are looking for a research partner, okay, or some kind of a collaborator or other skill, share, and slowly you will find some of those collaborators. Okay. Today, end of the day, we are going to do an intermediate course evaluation. So Professor Aisha Chaudhary, right? So maybe you can briefly talk about it, and then end of the day we'll do it.
These are some forms which we can fill today and we give it back today. So that would be and then
Okay, great. So it's usually designed for end of the course review, and that's something which the MHRD can use. However, if we do something in the middle of the course, that helps us adjust rest of the course. So if there are things that you want changed or adjusted, it gives us an opportunity to look at that and make adjustment. Great. All right, and the last part is for day 5, we have some choices of topics. So I'm going to briefly mention those. So in terms of actually, first the schedule, just for you to, get a sense of what's coming up. So today we will mostly talk about spatial querying and spatial databases. Essentially in the SQL-like framework, how do we include spatial data types and operations? Tomorrow we are going to focus more on location-based services and spatial networks. This is something, again, many of you know as a use case, but we are basically going to computational model, conceptual, logical, predictable model. Day 4, the focus will be on spatial statistics and data mining. And day 5, we have a little bit of open play. So I listed, 3-4 topics here. When you get a chance, maybe click through. The first, okay, let me go bottom up. Actually, maybe from here, second. Couple of you actually expressed interest in emergency disaster management area. And it just turns out we had a project on evacuation route planning, or 10-year long activity. So this page actually lists slides, papers, abstract, and so on. So if you take a quick look at least at the abstract, see if that interests you. There was some request on this emerging topic called big data and within spatial big data. So this page actually has some of the simple writings and abstract. And then when I was talking to the faculty members in geography and so on, they wanted at least critical or urgent. And right now one topic that's tracking around the world is called Nexus of food, energy and water. There are different names for it. So certainly there are many initiatives in Europe, in US. India has had actually workshops on this since 2008 or 2009. And I ran one workshop to look at data science aspects of this, right? So this page kind of talks about it. So you can, so this is third. And then finally, nobody actually explicitly requested it, but talking to folks, it looks like, these are some informal stories. This is not about really content knowledge. So there is no mathematics and no computing in there. But this is the experience of computer scientists working with other domains, whether it was the emergency management or environmental scientists. So this has a couple of stories of how we develop these interdisciplinary relationships. Okay, so you're welcome to look through, and maybe in the intermediate course evaluation at the bottom you can write down your preference. So at least vote for one topic that you would prefer. So we'll pick maybe 2 topics which has most votes and spend the last day morning on those. Okay, great. So with this, let's go to this speech. Introduce yourself.
I was executing the granular planning. So I just want what I discussed with sir, like what about reflected? It's supposed to be dull lake. Google doesn't show it as lake.
So this is visual band or?
This is visual band, what is
Okay.
available on this thing. So actual map, the lake is like this.
Okay.
Like what I'm about reflectance, but Google you just cannot make it.
Right.
Google
right.
image.
Yeah, yeah.
So what we were talking to yesterday,
Oh.
now we use the predictive, the statistics for the rainfall,
Acha.
and then we simulated to see what is the submergence level.
Okay.
Because
Okay.
Srinagar went into floods last
Right.
year.
Okay. Okay.
So we created the alternate routes of what is like this blue line.
Okay.
What is
okay.
the route possible? Then check it in 3D.
So this is for people if they have to be evacuated
Yes.
from Srinagar? Okay.
And then we checked it in 3D.
Okay.
Whether it's workable or not.
Right.
And then the elevation profile, that if you have to cut
Right,
a road,
right.
whether the elevation works for the cutting of the road or not.
Not okay. So this is for new road construction.
Yes, sir, because
Okay.
in case the evacuation route gets this
Right. But this is a linear one. So this is along a particular
Yes,
candidate route.
This is this was the road. If you use the yellow line.
Okay.
I'm sorry, I couldn't get the.
No,
full
no,
print.
no problem. Okay.
So this is we were unsuccessful. Then we
Okay.
take an alternate route. We created
Okay.
one more road like this.
Okay. So you are looking at specific routes
Yes.
and see. Okay.
Then the placement of teams is green dots, red dots.
Okay.
And then making of helipads for evacuation.
Okay. So this is it. You are sending supplies and people to go and okay
And
shelter.
the
Yeah.
helipads for evacuation.
Ah. Okay. Very nice. So this is similar to what happened in Haiti earthquake and so on.
Exactly. So
Okay,
this is one subject
right.
which I want to work on.
Okay,
And the second
okay,
subject which I told
right.
you that prediction for those
Okay,
anti-terrorist
the risk one. So risk one actually, I don't know if you have searched on Google, search on risk map.
Sir.
So you will kind of see some of the things that are already done. But there are some products. But this one, if you are okay, and people choose emergency as the topic on day 5, then if you are okay, I'll invite you
No
to
issue.
share,
No,
right?
I'll share my-
Because it's good to have case studies in
Because
India.
this
Yeah.
was done live
Right.
and we saved about
Right.
1400 lives with you.
Wow, wow, yeah. No, this disaster response time matters a lot. So how long did it take you to do all these maps?
Sir, actually this
Right.
development took us about 2 weeks to be honest because
Okay, right.
most of us had
Okay.
surveyed the area already on ground.
Okay, okay.
And
Okay.
so we were able to do it.
So
and
this flood event lasted more than 2 weeks.
Sir, the flood was for 37 or 38 days.
Wow, wow.
The
Okay.
entire
Right,
Srinagar, so-called paradise on earth
right.
was submerged.
I see. Okay. Wow, all
That is the
right.
time we had worked there.
Okay. No, this is wonderful. And what may be nice is your computer science colleagues would love to say, can we cut down from 2 weeks to 2 days or 2 hours, right?
Because
So
the
it
first
will be.
attempt,
Yeah.
nobody had tried it before.
Yeah, no, this is very, very nice. And same thing, when they do hurricane, do they do pre-planning? Because Andhra and all, when hurricanes come,
Sir,
they go
I
and
have not had
evacuate
an
it.
opportunity of coming down, so
Okay.
but I would love to work there.
Work those, okay. No, this is a very important area. It will be very nice to share.
The state government data
Yeah.
on the rainfall and
Right.
groundwater.
Yeah, and just to simulate that. But, by the way, Google is only one satellite imagery source.
No, I agree, sir. You
Right.
have Landsat, you got so many
Yeah,
available.
yeah. And what happens in other satellites, it goes, it gives you a scan very often, right? Weekly or sometimes daily. If you look at some of the new satellites. So if you do compositing, right? Because see, the reason Google cannot see it, you may have really bad air pollution, right? You may have dust, you may have cloud cover.
That is
but
the myth I want to clear that people say Google pe dikhta hai and sometimes
no,
you
no,
just
no.
can't make out.
No, Google is, it's just for broad consumer
yes.
awareness, right? But India has very good satellites. So if you do compositing, right? So, but again, it has to be the right time. In Delhi, in winter, every morning is fog, right? So, but if they schedule it, so then you get a couple of clear days, then we can see a little better. Yeah, yeah. But this is also very nice. So you basically took the elevation map and you put
I
the
took
rainfall
elevation map and
Yeah.
I took the rainfall
profile. Okay.
and then saw how much is the submergence.
Okay. So you just simulated the rain going, where will it sink, right?
What is
Okay.
the, in case the rain is 10 centimeters,
Yeah.
how much is submerged?
So I have one exercise. Maybe we should use it tomorrow, which basically gives a little elevation map and says, suppose water goes down gradient, and if this is the rainfall, where will the water go? Maybe it will relate to your exercise, right? So tomorrow we'll maybe try that.
In
Yeah,
fact,
yeah.
this is what I want to specialize in, and second
Okay.
is that emergency, what I told you, risk management.
There, okay, good. So yeah, please vote for that topic. But I heard few other people, and I said we can certainly share. Yeah,
What we can also do is,
Right.
we are planning to have a 2-hour lecture in
right,
computer science.
right, yeah.
Topics that don't get selected.
Yeah, use
keep
that.
them there and
Right,
invite
invite
everybody.
everybody there. Yeah, we can also do that. Yeah,
So that also
Great.
everybody is happy.
great. No, these are nice maps, so I'll call on you to share. Yeah. Do you have soft tomorrow or something if you bring it? Yeah, great. Yeah. Sure. Copy. Yeah. You can email if you like. You can email to either me or to one of the faculty members. Then you don't have to bring soft copy, or bring it on a memory stick or something.
I'll get on a memory stick.
Yeah, great. All right. All right. If you see my hand raised, please raise your hand. Okay. If you see my hand raised, please raise your hand. Let's get back together. I hope you at least met one new person, and during coffee break and so on, I hope your conversations will continue, and you will try to make some more friends and find interdisciplinary collaborators here. Okay. So today, all right. So today we will take a detour to spatial database, and the first part of lecture is just a review of SQL, and I'm assuming many of you might actually know that. So again, a quick show of hand, how many of us have used SQL before? Okay, it's about half. That's good. So in the early part, just to be patient. The goal actually is to reach the OGIS simple feature types. Okay, that's what we are going to do. We can experience this OGIS data types and operations through many programming language. You could use Python if you're coming from ESRI environment. You can use it in Java, but those languages tend to be more verbose, whereas SQL is much more compact. So we can convey this idea much more, in a much fewer lines of code through SQL, and that's where we are going there. Okay, so let's very quickly look at this notion of query languages. So we'll talk about what is a query language. Have a very simple database with couple of tables which will have spatial component. Quick overview of SQL, including the select statement. So this is just a background. Our basic goal is to come over here. Okay, that's what we are really aiming towards. And I will also motivate why all these OGIS data types were needed. If you didn't have that, life wasn't very pretty. And so that's an extended example. Okay. Once we are done with all this, then at least we'll know how to use this. Second half, we may get into a little bit of mathematical basis of these OGIS operations, okay, which is the next set of slides. All right. So the first part I will try to go a little bit quicker, but this is where we want to spend most of the time. Okay. So let's just quickly review the notion of queries, and most of us know that very well. You might have used Google Maps to query some information, or Siri and other things. So in general, querying is some kind of a question you're asking to a system. It could be as simple in GIS as a mouse click. Okay, so most GIS and maps, they have a default query associated with the mouse location. It may give you place name or elevation and so on. Or if you were in a search engine, you might type in keyword, right? And that gives you an implicit query saying that give me the documents related to these keywords. But in case of SQL, we write a small textual statement like this, right? So this is a select statement in SQL, which is saying give me names, the name column from this table, senator table, and here is a restriction. So essentially this is asking for female senators, okay, from that table. So these are different ways to specify questions. You could also specify it in natural language. And nowadays that's picking up a lot with applications like Siri or Alexa and so on. Okay? Or you could write programs. You could write Python, Java, and so on. And these are different trade-offs in each of them. And I said we will focus on SQL, which is most popular in the database world. And even systems like Siri and so on, in the back end, they all run on a database. Even GIS, ESRI software. GIS is really two components. In the back end, it is a database. Okay, it is SQL-based database, but in front end, you may have a nice graphical user interface to show you the maps. Okay, and the same thing is true about most large information systems. This is the heart of almost every information system that you will come across. Okay, because you may or may not see this directly, but that's what runs behind for even Google search and so on. Okay, all right. So in this environment, we'll use a very simple example. We'll use a database with 3 tables. Let me show you that, and then we'll use those tables to illustrate the details of this particular language. Okay. So the next module, very quickly, we are looking at an example database to illustrate this one. So in this database, we have 3 simple tables. Okay, we can be calling it entities. So there is a table about countries, a table about cities and rivers. And from a spatial perspective, you can guess why we are picking those up. So cities will be represented very simply by one point, which is the city center. Countries by a polygon, which gives you the boundary. And as you guess, river will be represented by a center line of the river, right? So you have 3 geometric types. You may have some relationships which are non-spatial, such as a city may be capital of a country, or a river may originate in a country. But in addition to that, we'll have many spatial relationships, such as a city may be inside a country, or river may cross a country, and so on. Okay? So in databases, we often make a high-level diagram called entity relationship diagram. So here we are showing the 3 main tables, city, country, and river, as boxes. And each table then has columns. So when you see ellipses, so city has a name and population, and whether it's a capital or not. Country has things like name, continent, population, and so on, and so on. River has these. The traditional entity relationship diagram has been changed slightly here. So first, how many of us have used entity relationship diagram before? Few of us, a lot of us, good. So tell me what's unusual about this diagram, which you probably didn't see a lot in your other case tools. The symbols, you notice I have marked them by spatial data type. So this is what we call pictograms, and it actually simplifies your ER diagram. Okay? But by declaring them spatial, I don't have to actually make spatial relationships. I don't have to list city may be inside country, because these can be inferred just given the geometry. Okay? So it's a simplified diagram. All right. So let's quickly then look at the table schema. And again, most of you have probably seen this syntax: table name, and then listing the column names. And I have left out the data types for now, but you can pretty easily guess the most interesting are these geometric types, but these things may be string or numbers and so on. Also the primary keys, so very simple primary key, and then these are the foreign key relationship. Okay. So this is also showing you the content of the table, just for people who, just to refresh. So country table, you have these columns: name, continent, population, and so on. So here are some examples. Canada is in North America, about 30 million people. This is GDP in dollars, life expectancy. And then I have left out the actual polygon, but probably from world map, you know what polygon is being referred to. Okay? Same way city, a few cities named here, which country, population, whether they are capital or not, and a very simple geometric representation. River, okay, again a few names of river, country of origin, length, and shape, and so on. Okay. So very, very simple one, and this is what we'll use to illustrate these. Okay. Great. So let's quickly now delve into SQL. In this particular module, we'll quickly talk about 3 pieces of SQL, and we'll focus on one piece a little bit more. Okay. All right. So SQL, as you all know, is the standard language to interact with the relational databases. Stonebreaker calls it intergalactic data speak, right? It's really very popular. 1986 is when it was standardized, called SQL1. Since then, many other standards have come. SQL3, 2003 is what we would primarily be using. Okay? And there are many different brand names that some of you will recognize. There are also public domain versions like Postgres, MySQL, and so on. What I would be using would be mostly SQL standard, but if there are small variations across brand names, and we'll point that out. Okay. All right. So I said many standards, and in this world actually people do adhere to standard reasonably well, but there are cases, things like dates or even spatial where there are slight variations. Okay. All right. So in connecting it back to the GIS world, before 94. The GIS used to have its own custom database. So if you have come across ArcInfo, info is the database part. Okay? But roughly around 1994, ESRI realized that if they connected to the general purpose relational databases, it was a win-win. So they allowed this ODBC interface. So starting mid-90s, you can replace info by your favorite database, DB2 or and others. Okay? So and so this is sort of one thing to know. Second is that many applications you might see a pretty graphical user interface or a voice interface, but they usually generate SQL to talk to the backend database. Okay. All right. So SQL has 3 broad parts. There is a component which allows you to define the tables. So this is what we call data definition language. There is a part which allows you to then insert data in that table or change the data, and also query. So we will primarily be focusing about the querying, the select statement. And there is also a third part on data control. We are not really going to look at that a whole lot, But if you are interested in a lot of concurrent update or security and so on, then that's usually here. Okay. All right. So we are just primarily be looking at data manipulation and select statement. Okay. But a little bit on this, table definition. The ones we were talking about, you can there is a statement called create table. These are keywords. Here is table name, and then you can list the columns and their data types. So many of you have again seen this kind of thing before. So is there anything new in this create table statement for any of you? We see a new data type line string, some of us. Okay, good. And notice that this is being used in the same way as the other built-in data types like numbers or strings. And that sort of is the beauty starting SQL 3, which is about 2003. It was standardized, but some vendors were supporting it even a few years before. In starting SQL 3, SQL became object oriented. So you can essentially add new class libraries, and one of the most popular and one of the first class library that was added to SQL 3 was spatial, okay, the OGIS simple feature type. But since then you have many other one. You can add a XML library or a text library and so on. And all those data types then become part of the data type collection, and you can use them to, for example, type a column. All right. So, but other than that, the syntax in SQL is usually very simple. And this, if you know Python or Java and so on, this might remind you of statements such as struct or class, right? Where you give the type name and then the properties. But you don't see methods here in this particular syntax, but SQL 3 does allow that. You can also add methods if you did a create type. Okay. All right. Once we have defined a table, in case we need to change the set of columns or and so on, you have few other statements. We are not going to really worry about those for now. Okay. But here is a statement to start adding data. Okay. So now we are looking at data manipulation, and the simplest statement is called insert, and we are showing you a simple form which will insert just one row. Okay. So in this case, the table name is specified. So in the river table, we are adding one row, and the values are given here. So Mississippi is the value for the name of the river, USA is the origin, country of origin, and this is the length. Okay. So with this statement, you can add just one row. Okay. There are other variants of that where you can actually do bulk load. Okay. You can, if you already have data in another table and you want to copy it, you have a variant which can do that. Okay. So this is a bulk load, and same way you have a delete statement using which you can delete one or more statement which qualifies. Okay. All right. So all right. Just a quick review one, just to pause and in this fast-paced one. So we actually talked about a set of statements, and can one let's have a show of hand. Which of these is not in data definition language? Remember, we had three components: data definition, data manipulation, and data control. Okay. So how many vote for create? Okay, vote for drop. Vote for alter. Okay, vote for insert. Okay, so insert is actually the correct answer. This is part of data manipulation language with select and so on. These three are data definition language. You create a new table, you can drop that table, and here you can change the schema of the table. So usually alter, you can add a new column and remove a new column and so on. Okay, okay. Just some vocabulary. Now let's play with select statement, because through which we will experience a lot of these spatial predicates and data types manipulation. Okay, so we'll quickly show you simple select and multi-table select, and also give you some tips on how to compose select statement. Okay. So one table select is something a lot of us know, even if you may not have course on database, but average programmers are they are often expected to interact with the database, and they all write at least a single table select. Okay. So this should be pretty simple and familiar. Okay. So the purpose of select statement is to fetch data from the database, right? As I told you, most applications they are structured like client and server. So your graphical user interface may be client, it goes to a backend database, fetch the data, and then show some graphics things. Okay. So it usually works where input is a table as well as output is a table. And this has this select statement has many clauses. Okay. So we'll show you a few of them, and you can also invoke operators, functions, and things of that kind. So let's actually observe a few of them. Okay. So let's start with simple clauses. Okay, this is about 6 clauses, and we'll start with the simplest one, select and from and where, and then add. Okay. So the mandatory clauses are 2, select and from. Okay. In the from clause, we list the tables, and select clause, we list the columns that we want, and we can also attach operators. Okay. So very, very simple cases, just like the hello world example, and then we'll make it more complicated. Now, once you go past this, the most popular clause is where you can restrict the set of rows that we want. Okay. So, and then you can do more. So let's go step by step. And I said you can also do arithmetic. You can look at different comparison. So if you're coming from Python or Java, you can kind of see more manipulation here. Okay. So a lot of these details can be added, but let's go through the example. Don't worry about the list for now. Okay. So suppose we want to work with this city table and list the cities with their countries. Okay. So in this one, notice that city table already has many columns. So we are just looking for these 2 columns, the city name and country name, 2 columns from one table. Okay, that's all we are looking for. So for this, you just need 2 clauses. Okay, the from, so this is the result. So you need the select clause and the from clause. Okay, so that's the result we are looking for. So you list the table in from clause and the columns in the select clause. Okay, so this is the hello world equivalent for SQL. Okay, if you are new to it, hopefully this is a quick introduction. So we can make it a little bit more complicated now and bring in the where clause as well. So just like you saw, the select clause allows you to take a subset of columns, the where clause also allow you to take subset of rows, right? So in here, as you notice that now we want some columns like names, but there is a restriction. We don't want all the cities. We only want cities which are capital of their countries. So this row restriction will go in the where clause, and we can essentially want to see a result of this kind. So name, but notice that capital column is all true. Okay, so that's the where clause condition. Okay, so again we specify the table, we specify row restriction that capital column should be Y, and then we are listing the set of columns that we want. And so we introduced also an acronym here. So what does star mean? Which columns are we looking for? All of them. Okay, so it's a wildcard. So this is the next one, and this is probably the most common form of SQL statement you might see with select, from, and where. Okay. So here is now a query where we are trying to restrict both rows and columns. So 2 columns. Okay. And so this is the subset of columns, subset of rows. So now you are seeing select. Okay, so that's the result. And notice, the tables are always listed in from clause. Okay, the columns that we want are in select clause, and the rows that we want, those are specified through the where clause. Okay. Another small syntax that we are introducing, you notice that this table name also has been aliased, so that we don't, we are not using the exact table names here, but we are using an alias. Okay. Great. So quick pause. Any quick questions for people who are new to SQL or select statement? Any surprises? Anything you want to discuss? Yes. Okay, very good question. Somebody who has used SQL before, could you tell me a motivation why are aliases used by programmers? Yeah.
When we're working with multiple tables,
Right.
you might want to make some check statements using 2 tables, whether this
Right.
specific row matches
Okay.
for the 2 tables, and we display those records.
There. Wonderful. Wonderful. So the more exact answer is what you are getting from there, but let me give you a simpler answer first. So here I didn't want to type this long name country, so I used a shortcut. Okay, so that's often a convenience answer, but really in this case I didn't need an alias. Okay, the more technical answer you got is where definitely you need an alias. Is, for example, suppose I want pairs of countries. Okay, pairs of countries with certain spatial relationship like neighbors. Suppose I want to ask you which country in the world has highest number of neighbors. And that's actually an interesting geography question. Those of us who watch the map think about the actual geography answer. But in SQL, in order to answer that, I need 2 copies of the country table. Okay, and now if I am using the table twice, then I have to disambiguate and say when I am looking at the column, am I looking from the first copy or the second copy? And using alias, you can have two names. You can say country CO1, comma country CO2, and now you can refer to column from each copy uniquely, right? Okay. Now back to the geography quiz. Who knows which country has most neighbors? China. Okay, that's pretty good. It's either China or Russia, but they probably are very close to each other. Yeah, great. All right. Any other quick questions on the basic select statement? Which Indian state has most neighbors? Okay, I actually don't know the answer. So maybe people who look at the map, please look at it. It will be one of the middle states, either Madhya Pradesh or. But take a look. It will be a curious thing to do. Okay. 6 states. Okay. So if you can beat 6, then Maharashtra. How many are there? Because they have very big neighbors, right? It's only 4, yeah. Okay. All right, so let's continue forth. The select statement has other clauses as well, using which you can do some very basic statistics and sorting, okay? So here, as I said, now you notice a small amount of statistics coming in. We want to look at group of capital cities. They all have population, but we don't want population of individual cities, but a statistical average, okay? So in this case, we introduce some new clauses, group by, and then you can also do having, okay? So, so for if you want just a single statistics, then you don't really need group by clause. You can still live with select from where, and simply use a statistical function in select clause. And this is showing that. So first you always start with tables. We just want city table. Then this is the subset of rows. We only want capital cities, right? And then this is the column we want population, but I'm not looking for population of individual city, but I do a statistics. Okay. So if your answer has just one number, one statistics, max, min, average, and so on, this is sufficient. But we can also do group by statistics. So look at the next query. Now in this case, actually I have many continents, right? 6 or 7 continents, and for each continent I want a small statistics. So to carry out this query, I need a new clause, a group by clause. Okay. So here we start with the table. Okay. So countries have GDPs. So this is the table, and then I make subgroups, right? So out of those roughly 200 countries or so, we make group by continent, right? And then for each of this group, I can look at the average GDP. Okay. So this is the continent, and that's the average for across all countries in that continent. Okay. So this is showing you a simplest use of group by. So if you have a collection of things, we can make subgroups and do basic statistics. Okay. All right. So going a little bit further, so we're going to introduce one more clause. So you can also have a having clause to select the subgroups. Okay. So just like where clause was looking at subset of rows, having clause can look at subset of groups. Okay. So in this case, we are looking at this river table, because river table has country of origin, and then we are going to group things by country of origin and say, well, only give me countries where at least 2 rivers originate. Okay. So river, they are grouped by the origin, that's a country, and and within that each group we can count, just like average you have a count. Okay. So count has to be at least greater than or equal to 2, that's greater than 1. And then finally the select statement. So it's grouping by the country of origin, and then within that we are also doing another statistics, okay, smallest length. Okay. So this is now showing you select from group by and having, and you have now seen most of the clauses, okay, of select statement. Okay. Good. So the idea of SQL was that in very few lines you can express reasonable number of data subsets as well as symbol summaries. And the goal actually was, when this language was being designed in early 80s, people thought that even non-programmers, like managers and so on, who often have to explore data, they would be able to write this. Okay, so the language was designed in that purpose. But it turned out now that you have so many nice interfaces around, very few non-programmers actually go and do this. Okay, but they could. All right. So we are almost there, and the part of select statement that you learned right now, you are probably close to average programmer in the industry. Okay, most programmers in the industry, they are usually trained on procedural language like Java or Python and so on. And then since they have to use the databases, they will use select statement with usually one table. Okay, that's very typical practice. So next I am going to show you multi-table select statement as well to show you the power of joins, okay, which is a natural thing to do in SQL. But in industry, oftentimes you will come across code where they don't do that and they put a loop around a single table select. Okay. So, but again, quick show of hand, how many of us have used joins in select? All right, so about under half. Okay, good. So let's take a quick look, and as I said, people who haven't used it before and this looks new and tricky, don't worry about it. You already got the crux of SQL. If you can at least get started with single table, it brings you almost same as industry average, and then as you need more, you can pick up more. Okay. By the way, this is where also we separate out from GIS. If you are doing point-click queries in GIS, it's much more natural to take care of one table queries. Okay. But the real power of SQL starts to show. You really start to separate from point and click interfaces when you start doing joins. Okay. So let's take a look, a very quick one, and I'll also give some tips on how to handle these kind of statements. So idea here would be to use now multiple tables in a select statement, and I'll talk a little bit about how you can compose at least the simple cases. Okay. All right. So let's look at this question. So we are now looking for capital cities and populations for countries where GDP exceeds this. Okay. So in this case, the first question is, we have to say how many tables do I need? Okay, how many tables do I need? So first look at in the country table, we do have a few things, right? So country table does have population, so I can get that from country table. It has GDP, right? So I can get that from country table as well. But is there anything we need in this query which is not in country table? Capital cities, it's missing, right? And that is in the city table. So for this query, I need two tables, city table and country table. I need more than one, okay? And because of that, I need to think about joining two tables, okay? Good. Everyone comfortable with this query that you're looking for multiple tables? Okay. So as I said, the capital city information is in the city table, down here. Okay. All right. So in order to do that, we need to essentially use this join condition and try to bring the two tables together. Okay. So in order to do the join, the basic hint is, so this is the city table, this is the country table, and in relational databases, a vast majority of joins are based on primary key, foreign key join. Okay. If you know entity relationship diagram, that's one of the relationships in your schema. Okay. Vast majority, not all, but vast majority. So when you are getting started, always look for those. Okay. So when I am looking at these two tables, the country table and the city table, then you will notice that this country name is sort of is matching this column country in the city table. Okay. So this is called the foreign key, right? And this is what is being matched with the primary key of country table. Okay. So this is your primary key, foreign key matching condition. And when you are starting out, this is a pretty decent heuristic. Always try to look for those. Okay. All right. And so this is your join condition, and then we can start putting other conditions. So we want to make sure that in the city table, the capital column is yes, and then you will check for GDP and so on. Okay. So here is sort of the query. So now the big change you see is the from clause. You have two tables, right? City and country. We got the join condition down. Okay. And now we are going to fill up the other parts. Okay. So first in the select clause, what columns are in the result? We want the names of these cities and population. So those are down here. And then the remaining conditions, we want GDP exceeding $1 trillion, and we also want capital cities. So those sit in the where clause, right? So we have slowly now composed. So these, this is illustrating equijoin power, and that's where SQL starts to separate from languages like Java and Python and so on. Okay. If you didn't have this equijoin condition, if you didn't use it, then in those languages you will have to set up a loop, okay, on one of these tables, outer loop, and in the inner loop you can go and do single table queries. And if you look at the code written in industry, actually you see that a lot, right? And it's fine if you are not getting into performance problems, but if you are running into performance problem, switching from that looping to a equi-join usually will help a lot, because databases are engineered to perform these joins very fast. Okay, they have multiple algorithms and data structures. Okay. Great. Any quick questions, issues here? All right. So I'm going to make these examples a little bit more complex, and then we'll go to the spatial one. Okay. So when you're writing these multi-table queries, it often helps for you to ask 3 questions before you actually write the code. And I will go through these meta questions. And at least for simple queries, that will really help avoid many mistakes. Okay. So first question in these you should always ask are, okay, how many tables do I need, right? And pin those down. Okay. And so this is sort of an initial list of tables. The second question is, how will I join these tables together? And as I said, in the relational databases, the best way to answer this is to look at your entity relationship diagram and see a path in that diagram among these tables. Okay. If you are lucky, these tables will be connected directly. So you will just find direct join conditions in this list. But in a larger schema, oftentimes you might actually see that these tables are not connected directly, but you have to bring in additional table to create a join path. Okay. And in that case, this would actually enhance this list of tables. All right. Another complication sometimes that happens is you may have actually choices for join paths, and you will have to judiciously choose the proper join path. Okay. In some cases that is an ambiguity. You have to maybe go back to the user and ask, look, I have 2 possible join paths, and if I follow them, these are the different meanings, and try to tell me which one you prefer, and so on. Okay. So these questions look very simple, but depending on the example, you might have to exercise caution and judgment to answer them. Okay. And then finally, you want to judge whether we need any statistical aggregation or not. Okay. If you need that, then this will tell you whether you need group by having those clauses. Okay. And as I said, if you can just go through these steps before writing multi-table queries, it will avoid a lot of common mistakes. Okay, so let's look at this example. So now we are looking at names, population of capital cities of countries where this river originates. Okay, so let's go through these questions quickly. First is how many tables do I need? In fact, let me give you 30 seconds. Why don't you talk to your neighbor before we come back and take a class answer here? So talk to your neighbor and discuss, do we need 1 table, 2 table, 3 table in this case? So it is about 10:30. Is it okay to go another 10-12 minutes before we break? Yeah. Okay. So I'll finish this chapter. Okay. Yeah. All right. Okay. Sorry, but yeah, continue. Yeah, continue. Okay. Okay. So river. Okay. Okay. All right. So let's get back together. Okay. Let's get back together. So how many of us think we need one table? All right, okay. How many think we need two tables? All right, few. How many think we need all three tables? Okay, most of us, okay. All right, so let's try to analyze and see. We certainly see the river table, right? Is certainly there. And we also see the city table because we need information about the city. So the big question is, do we need the country table or not, right? Because the query directly didn't ask anything about it. Country information is in there in river as well as in the city. So question is, could we join river and city, or do I need to go through country? That's the big question, right? So yeah, so that's the big question. And this population you are saying is ambiguous. Is it the population of the city or population of the country?
Yeah, that's population
City, yeah. So let's suppose it's for the city, right? So keep it a little simple because that's an ambiguity. English or natural languages are ambiguous. In this case, you should certainly consult your end user and clarify it. But suppose I say, well, this population is about the city. Okay, disambiguated. All right, so let's look at at least the solution on the slide. And this one actually chooses all three. And probably the logic is the following. Okay, so if you remember your ER diagram, there is no direct relationship between city and river. Okay, in your ER diagram, the relationship went through the country. Remember that, right? So if I am following your ER diagram properly, then in order to join city and country, city and river, I have to go through country, right? So that's why this is favoring that. Okay, although in this schema you might have been able to get away by simply taking river, city dot country and joining it to river dot country. You probably could write that, but by doing that you are taking slight risks. Okay, so databases, the mindset is very different. Data quality matters a lot. Okay, this is very different from Google. When you do Google search, right, in your result there are lots of mismatches and your result is not complete, right? Same thing happens with Siri or Alexa, right? So a lot of applications, our expectations are probabilistic. We say, I want lots of relevant things and I don't mind missing a few things. But SQL doesn't work that way. SQL is much more precise. You want your result to be correct and complete. Okay, and in fact, SQL, if you look at its system, it has integrity constraint. It has foreign key constraints, and all that is to control the data quality. And the reason is SQL is used for places where data quality matters a lot. For example, if you do taxes through software, right, back end, you want your taxes to be correct, right? If it is incorrect, the government doesn't like it, right? Companies, same way, when they do their financial statements, the CEOs are now responsible in US, and if there are big errors, they are legally liable. So there are a lot of applications where you can't just do probabilistic things. You have to be correct and complete, and SQL is about that. For example, on e-commerce, when you order things from Amazon and so on, how would you like your orders to be probabilistic? Would you like that? Probably not, right? When you order something, you want it delivered, and that's what SQL systems are about. Okay, so here, even though you could join this directly, but if your data quality is not perfect, you might have errors, and the proper thing to do is to go through your schema, because then all the data, integrity constraint, including your referential integrity constraints, are being imposed. Okay, all right. So 3 tables. The next question is, how are they joined? So if you remember your schema, there was a join path. So city.country will be joined with country.name, and same way river.country will be joined with country.name. So that's your join path in the schema. And once we have done that, the last part is, do we need group by having in here? Okay, how many think no? How many think yes? All right, third question. Yeah. Third question, is there any statistics going on? Okay, most think no, right? Okay, good. So we don't need that. Now we have enough information to compose the select statement. And I said this will go to from clause, this goes to where clause traditionally. Although newer from clause, you can include join conditions too. Okay. So from clause are the tables. Okay, here is the join condition, and then we fill out the select and rest of the where. So in select, all we need are the name and population of the city. So notice this is the city table information, and then in addition there is some other condition. St. Lawrence River has to be added as the where clause. So rivers, country of origin is Sorry, river.name is St. Lawrence. Okay, good. Any questions, issues on this one? Feel comfortable? Little bit louder. City should be capital. We still need the capital, and that's on our condition. Good. All right. Other thoughts, questions, and so on? Okay. So we'll just move forward with this. As I said, we can show you more examples. Now we are putting some statistical one. But I'm looking at the time, and probably I think in the interest of the time we may want to maybe skip rest of the multi-table query. You are welcome to go through those. You can treat it as an exercise. Maybe we'll do it in the tutorial. And what I would basically like to do is to maybe take you to the end of this section, and we'll go to a break. When we come back, we'll look at the spatial extensions, and as well as the mathematical model underlying the topological operation. Okay, so let me just see, how long is the break now? Just like a couple of minutes, and we take the tea break afterwards. In terms, come back at 11. Okay, good. So we take 20 minutes break. We'll resume at 11, and at that time we will essentially say how do we include spatial predicates and data type. Okay.